Hello everyone, this is the project of tall building design by Skyfi Labs. So here is the problem. First we have to draw the building in etaps. So first I have to open etaps and create new model. Okay, I'll just use the built-in settings, which is display units metric SI, Indian, and steel and concrete design code as per Indian standard. Click OK. Now in the grid size you can see the problem. In the bottom story there are 4 grid lines and 4 grid lines in the horizontal and 4 grid lines in vertical, I mean X and Y direction, and the spacing of the between the grids are 6 meter. So 4 and the spacings are 6 meter and 6 meter. Now for the story data, it has G plus 23 stories and all the stories are 3 meter high. So number of stories will be 23 and type of stories will be 3. Now here you can see there are different heights of stories. I mean there are similar stories in different heights. So we have to go for custom story data. Here you can see story 1 and 1 to 8 are similar, and 9 to 14 are similar, 15 to 19 are similar, and 20 to 23 are similar. So we have to now story 1 to 8 is similar. So I am making story 8 as master story, and all the remaining stories as similar to story 8. Setting the stories between 1 to 7 as similar to story 8. Now story 9 to 14. Story 9 to 14. Okay. So we have to set story 14 or any other stories as master story. Now we have to change the remaining stories below that story similar to story 14. Okay. Story 14. Story 14. Now story 15 to 19, I think 15 to 19. Okay, story 15 to 19 are similar. 15 to 19. Now I am making 19 as master story and all the remaining lower stories as similar to 19. 19. Okay. Now all the similar stories are set. Now click OK. Click grid only and click OK. Now the grid line for the building are designed. Now we have to define the material properties. Here you can see the concrete and rebars details are given. M40 concrete and HOSD 500 and mile grade 250 rebar are given. So we have to define these. Go to define material properties and then add new material. Region as India, material type concrete and M40. Okay. Now click rebar, HOSD 500, right? 500. Now again click add new material, rebar and mile grade 250. Now all the material properties are defined. Now you have to define the frame properties, frame sections and other slab properties. First we are defining frame sections. Now you can see here are 3 beam properties are given and 3 columns properties are given, and we have to use the auto select property. So I am first defining the column sections. Give the name C 500 into 500, right? 500 into 500. Okay. Now the material as M40. Change the dimensions. 500. Modify so rebar. This is column, so M2 M3 design will be selected. Longitudinal bars HOSD 500 and confinement bars as mile 250. And the clear cover is 40 mm given, so we don't need to change that. Now click OK. Now we are going to make a copy of that property. Add copy of that property. C 550. We just have to change the dimensions here. All the rebar properties are same. Yeah. Now click OK. Now again click add copy of property. C 600 into 600. Here 600 into 600. Click OK. Now I have to select the auto select. You see auto select command. Now click add new property. From here you can see here is the auto select list. Click that. Now we are giving it a name, column auto select. Design is concrete. Now we are going to add this column to this list. Okay. Now we are going to define the beam properties. Add new property, concrete rectangular. Give it a name beam 500 into 300. 500 into 300. Material as M40 concrete. 500 300. Now modify so rebar. This is beam design, so we have to change the design as beam M3 design only. Longitudinal bars HOSD 500 and confinement bars mile 250. The covers are 25 mm and 25 mm for beam, so we have to change that. Now we'll be copying this property. Beam 550 350. 550 350. Right, 550 350. Again I am copying this property. This will be beam 600 into 400. 600 into 400. Okay, now I am going to add the auto select property, auto select list. Now giving it a name, beam auto select. Design type as concrete, and I am going to add the beams. Click OK. Now while designing, we have to select the beam auto select and column auto select option while drawing the beams or columns. Now click OK. We have to define another property, which is slabs, 150 M40 slab. Okay, define section properties, slab sections. Add new property, give it a name, slab 150, slab material as M40, change the thickness to 150. Now click OK. Okay, all the properties are set, I think. Now we just have to draw the building. Now we are drawing from the story 1 to 8. So I am going to story 1 by clicking the move up in list. This is base and this is story 1. Select similar stories in the drop down menu. Now we are going to use the auto select, quick draw columns, and change the property to column auto select. Now we can see from story 1 to story 8 all the grid lines are covered. So you have to select the whole thing. You can see all the columns in story 1 to 8 are drawn. Now we have to select the quick draw beams. Change the property to beam auto select, and okay, beams are drawn. Now we have to select the quick draw floor option to draw the slabs. Select the property slab 150. Okay. Now we are going to move to story 10. Okay. Click plan view, story 10. Okay. Okay, story 9, 1 to 8 was there, and story 9. You can go to story 9 or story 10, it doesn't matter. So first I am selecting quick draw columns. Now you can see here in the pictures, from the grid lines you have to draw these columns. Okay, first I am drawing this and then this. There will be no columns in this and this. And you can see the properties were always also set to column auto select, and here is beam auto select. Now I am drawing the beam. Okay, beams and columns are drawn. We have to draw the slabs. Slab 150 is also selected. Okay, beams, columns and slabs are all drawn. Now go to story 15. Story 15. Okay, make sure similar stories are selected. Story 15 to 19, this is the plan view. Okay, so first I am drawing the columns. Okay, now I am drawing the beams. For the slabs, I'm just selecting the shortcuts here. You can also use draw beams and columns and quick draw columns or beams. Now go to story 20. Here you can see the plan view of the grid line. I'm selecting quick draw columns and then quick draw beams, then quick draw floor walls. So all the beams, columns and slabs are drawn. Now we are going to draw auto draw cladding. Select the auto draw cladding, use floors and okay. So now I'm going to go to the base. Now select all the joints and go to assign joints and extents. You have to fix these joints. Fix. Okay. The building is drawn and the properties are also given. So now we have to give the loads. You can also select the extruded view to give it a look just like the problem. Okay. Now what we are going to do, we are going to give the dead and live loads. Now you see all the dead loads are same for all the stories. So we'll see all stories and go to story 1 and select all the slabs. You can see all the slabs are selected. Now go to assign cell loads uniform. This is dead load. What is the value of the dead load? 2 kilonewton per meter square. I'll give the value 2, click apply and OK. Okay. So the dead loads are assigned. Now click similar stories. You have to assign the live loads. All the live loads are different for each story, each similar stories. So story 1 to 8, the dead load, the live load is 5 kilonewton per meter square. So from story 1 to story 8, make sure all the cells are selected. Go to assign cell loads uniform. From the load pattern drop down list, select live and the load is 5 kilonewton per meter square. Apply OK. Now go to story 9. Select all the slabs. Carefully select the slabs. Now story 9 to 14, the live load is 4.5 kilonewton per meter square. Click assign cell loads uniform. Load is 4.5 kilonewton per meter square. Now go to plan and plan view. Select story that was 9 to 14 and story 15. click OK. Select the slabs. Here the live load is 4 kN per meter square. Select assign cell loads uniform, and this is 4 kN per meter square. Apply OK. Now go to story 20. Select the cells, click assign cell loads and uniform. The load is 3.5. You can see the load is 3.5 kN per meter square. Okay, now in that roof, in story 23, in the roof there will be no dead or live loads. So go to story 23. Okay, select the slabs, assign cell loads uniform, delete existing loads. Now you can see all whether there are any loads on this cell. Okay, yes, there is lead load. So click the two cells, click assign cell loads uniform, select dead and delete existing loads. Now you can display load assigns cell dead load. There is no load. Display load assigns cell live load. Yeah, no loads. Okay, so the dead and live loads are also given. Before analyzing, you have to give the wind load, and yeah, also the cladding load. Cladding load is 0.2 kN per meter. So to give the cladding load, we have again we have to go to the story 1. Story 1. Click apply. Make sure similar stories are selected. Carefully select the external beams. Because the cladding loads will be in the external beams. Yes, all the 96 frames are selected. Click assign frame loads distributed. Now here uniform load 0.2 kN per meter. Click apply, click OK. Now select plan, story 9. Select the external beams. Click assign frame loads distributed, again 0.2. Plan story 15. Story 15. Okay, select the external beams. We have to select carefully or other elements might get selected. Okay, now go to assign frame loads distributed. Okay, again select plan view, story 20. Select the external beams. Assign frame loads distributed. Here again in story 23 there will be no loads. So go to story 23. select the external beams. Okay, I have to select one story option. Select display undeformed shape. One story option. I think I have made a mistakes in cell loads. Okay, uh, one story 23 is selected, and assign frame loads distributed, delete existing loads. Okay, display load assigns frame. Display load assigns. Okay, undeformed shape. Now go to story 2020. Select display load assigns cell live load. Yes, we have removed the live and dead loads in all the similar stories. Anyway, I am repeating the step. Select both the cells, click assign cell loads uniform, dead load. What is the dead load? 2 kilonewton. I think 2 kilonewton per meters. Yes. Click apply. Okay. Again, select the cells, assign cell loads uniform 3.5. This will be live load, right? 3.5. Okay. Now go to story 23. Select one story. Select these stories, assign cell loads uniform. First delete the live load. Now we will be deleting the dead loads. Okay. Now select display load assigns frame. Yeah, frame loads are there. Okay, now I think the assigning loads are complete except wind load. So for wind load we have to consider Bangalore region. So first we have to define the wind load. Select define load patterns, and here select type wind load. The type is wind. IS code is 875 1987. Now click add new load. Now click modify lateral load. The wind speed in Bangalore region is, you can see in IS 875 from this map. In Bangalore region it is 33. You can see it is 33. It's not clearly visible, but it is 33. Now terrain category. Here the terrain category is 3 and the structure class okay, the structure class is also C. Structure class is C for Bangalore, and the risk coefficient is 1. Risk coefficient is 1, and the topographic A3 factor is also 1. Click OK. Now we are going to assign the wind loads. To assign the wind loads, we have to refer to the IS 875 part 3, table 5. Now I can see in table 5 the H by W ratio, the height by width ratio is between 3 by 2 to 6, and the L by W ratio is 1 to 3 by 2. So this portion, the portion of this table is suited for the calculation, and these external pressure coefficient factors are required for the analysis: 0.8, plus 0.8, minus 0.25, minus 0.8, and minus 0.8. Now go to story 1. Story 1, select apply, click OK. Okay, now we have to select the elevation view for for A. Elevation view for A. Oh god. Okay, now select the similar all stories. Wind is blowing from A left to right, so A will be the windward direction. Select the, you can see all the cells are selected. Here in 3D view you can deselect the use extruded view. Yeah, okay. Now you have to assign the wind load. Assign cell loads wind pressure coefficient. Now this will be windward direction, and the coefficient value will be plus 0.8. So coefficient value will be plus 0.8. Click apply. Okay, now the wind will also hit the some of the portions of the section B. So go to elevation view, select B, and OK. This will also be inward direction. Select assign cell loads wind pressure coefficient. Okay. Now the leeward direction, which will be section D and C. What will be the value? This section, the value will be minus 0.25. So go to assign cell loads wind pressure coefficient and minus 0.25 leeward. Okay. Now go to elevation view, select C. This will be also leeward direction and the value will be minus 0.25 also. Okay, now for the sides we have to select the elevation view, select one. Now all the sides, you can see here, all the sides are having wind pressure coefficient value of minus 0.8. So we can select all by just going up. You can see elevation view 2. What is this? See all the sites are selected or not. Okay. Now go to assign cell loads wind pressure coefficient. This will be minus 0.8 and leeward direction. Okay, now all the wind loads are assigned. Now we can run the analysis. Select the 3D view tab and go to analyze and run analysis. We have to save the file, tall building design. Save the file. Now the analysis will take some time. After the analysis is done, you can see the deformed shape of the building, and you can also check the shear force and moment diagrams of the building. Now you can see the deformed shape of the building is shown. You can see from the force diagrams, shell stresses and pressures. Yeah, you can see all the things here. Now we're going to design. Go to concrete frame design, view revise preferences. IS 456 is selected, so select concrete frame design. As the auto select beams and columns are selected, so here you can see 706 concrete frames are failing, so the software will run again the analysis on its own. Select yes. You can see it is analyzing again with higher beam and column sections, which is for beam 550 into 550 into 350, and for columns 550 into 550. Okay, 10 concrete frames are failing. Select those. It will run analysis again and design again. Analysis is done. Now it is designing. Again 10 concrete beams are failing. I think it is a software problem. Three beams and column sets are given, so after this, if the error occurs, it will be a problem. Just select no. Select them. You can see no beams or columns are selected. It was an error. You can see by verify all members passed. All concrete frame members are passed. So the design is complete. You can see the different details for columns and beams. The reinforcement details and all the section details are given here. You can see in the project reports as this is a evolution version, there will not be a detailing menu, detailing option, so I can do detailing, but the project report is, I can show the project report. So the design is completed. It will take some time to generate the report, but you cannot save the report because it is a evolution version of the software. Okay, this is the report. You can see the okay, the column base, floor base, all the details are here. frame sections properties, material properties. You can see material properties from section properties are given. All the story forces, frame forces, all is given here. Unfortunately you cannot save this report. Okay, I think this is it. So I'm going to save this, and thanks for watching.